Hi, I'm Chad with Mastercam, and in this video we're going to add some finish cuts to the Formula SAE upright using Mastercam's new Surface High-Speed Blend Toolpath. This new blend toolpath takes Mastercam's classic surface finish blend toolpath and improves upon it with a better interface, multiple stock to leave selection, avoidance geometry, and a faster, more powerful algorithm. Blend toolpaths will machine the selected machining geometry between two curves. The cut motion starts parallel to one curve and gradually morphs to be parallel to the second curve. This gives us much more control over the tool motion when we want something more complex than a basic raster or waterline toolpath. As you can see on the part, I already have a raster toolpath that will give me a good finish, but it is filled with unwanted retracts. Additionally, the holes and fillets are going to be finished in a later operation, so allowing the cutter to dip inside is wasted motion. Both the retracts and the wasted motion are going to add cycle time when cutting this part at the machine. I'm going to start by covering the holes in the model. The surfaces and wireframe that you see are all I need to create a uniform, flowing surface that our toolpath can use as a drive surface. On the Surfaces tab, I'll launch Power Surface and chain the upper wireframe loop. Once the surface is created, note that the checkbox for Use Normals is active. This is what keeps the edges of the new surface tangent to the surrounding surfaces. We can also adjust the stretch and bend parameters until we like the surface and click OK. The only thing that matters here is that this surface is tangent to its neighbors, which will eliminate any unwanted bumps in the tool motion. Now we can do the same thing for the lower pocket in the part. Power Surface will usually provide an ideal result with little to no additional work needed, but sometimes it may be necessary to adjust the number of UV control points to improve the output. In this case, everything looks good. I'm going to clean up the graphics view by moving the newly created surfaces over to level 4. Then I'll turn on levels 1, 4, and 10, and turn off level 3. The seed curve geometry on level 10 will act as the second chain that the blend toolpath will morph to from the outer boundary chain. I've also changed the color on the upper solid faces of the upright to yellow to make selecting the drive surfaces quicker when creating my toolpath. On the Toolpath tab, I'm going to launch Blend from the 3D Toolpath gallery. I'm going to set the stock to leave on walls and floors to 0, then I'll select my geometry. Since all the faces I plan to machine are the same color, I don't need to select them individually. I can use my quick masks instead. If I've forgotten which colors my target faces are, I can use the selection arrow and simply click one of the faces. All the remaining faces that share the same color are automatically selected, and a check is placed next to the color in the list. Using the quick masks to select items like this is a workflow that can easily be overlooked or forgotten, but it is incredibly powerful and helpful. All you need to do is take a little time to prep your model ahead of time, and you can save a lot of time and possible errors in machining geometry selection when you're creating your toolpaths. I can end my geometry selection, and then I'm going to set up my toolpath control. I'll select my drive curves, being careful to make sure that I select them in the same direction. Since the toolpath motion is going to transition from one drive curve to the other, if one of my drive curves is selected in the opposite direction to the other, the toolpath motion is going to try and follow that change in direction. On the cut parameters page, I'll set the toolpath step over to 30 thousandths and make sure the cut method is set to zigzag. I can now click OK and generate the toolpath. The resulting toolpath is a smooth, flowing, and nearly retract-free operation that will create a very nice surface finish. It's important to note that I didn't create a containment boundary, and yet the toolpath motion is nicely contained. This is because the toolpath automatically stays inside the boundary of the seed curves. Instead of creating a new blend toolpath for the upper legs of the upright, I'm going to copy the toolpath I've already created by right-click dragging and choosing Copy After. The drive geometry can remain the same, So the only change I need to make is to change the seed curves I've selected on the Toolpath control page. Again, I'm going to make sure that I'm selecting my change in the same direction. I can now click OK and generate the toolpath. The tool motion looks good, except for all the retracts between the two legs. I can eliminate these by containing the operation to only one leg at a time. On level 11, I have boundaries that I've created for each leg. I'll go back into operation 4 and select the first boundary as containment. I can click OK and regenerate the toolpath. Now I can copy operation 4 and reselect the containment boundary with the chain around the other leg. With all my operations generated, I can look at the operations and verify. Note the smoothness of the motion and the flowing nature of the cusps left between passes due to the large step over. Once the simulation is finished, I can compare the verified stock to the finished part model by clicking the Compare button on the Verify tab. The default tolerance band is too loose for this part, so I'll change them to a 0.002 increment, then refresh the Verify Compare results. The areas that we just finished are green, signifying that the finished faces will sit well within a 0.002 tolerance. Once the part is fully programmed, seeing an entirely green model in Verify Compare lets me know that this program will result in a quality part.